Check one, check one, check one. Hey, now I've got audio. All right. Hey, folks. Smitty Halibut here. Working on something, as I am wont to do, making sure my stuff is there. Yes, it is. Okay. Sorry, it's been a while. I'm still getting back into the swing of things. Smitty Halibut here, working on something. Today I'm going to finish up my bedside clock that I've been working on for a while now. And I made a revision. So it's a clock that uses WS2812s and a giant string set up as a 7-segment display. And so you can use a single digital output from your microcontroller to control all of these LEDs into different colors and making them display digits, and you can do all kinds of fun animations with them if you want, and et cetera, et cetera. I am using the ubiquitous, super cheap $2 WS2812, ESP8266. Really, Cat? ESP8266, the ESP01 module, which is dirt cheap, Wi-Fi enabled, super powerful, and it's got enough GPIO pins that to control all of this. I like the idea that it's Wi-Fi enabled because I want to hook it up to NTP so that my clock never needs setting. Similarly, I've got a 3 amp switching power supply here, so you give it like a there's a 2.1 millimeter barrel plug. It's kind of hard to see in there. There's a 2.1 millimeter barrel plug there. You give it 12 volts at enough current, and it will switch it down to 5 volts. And then it also has some USB ports on the side, so it doubles as a USB charger. So the idea is that this is a clock I can put on my bedside table that shows me the clock, and it can do things like it knows what time it is and what day it is, so it can calculate sunrise and sunset times and dim after hours. It can change colors because I like it to be red at night, but maybe green in the afternoons. Those kinds of things. But because it's going to be by my bedside, I have to charge my phone and my watch and my headphones, which are in the other room. I've got some AirPods. And so I like having 3 chargers there. They don't need to be super high power chargers. So I'll probably rig one of them up to be like a 1 amp and the others to be half amp charge ports. And yeah, so anyway, I did this original version of it. The display board works great. So the WS2812s are doing exactly what they're supposed to be doing. But the controller board, I made some mistakes on it. For starters, I didn't put any resistors on the data lines of the USB ports. So any device that you plug into that doesn't know how much power to be drawing. So I want to put some resistors in there to get that to signal to the devices hooked up to it how much power they should be charging. More critically, I was not thinking clearly. The ESP8266 is a 3.3 volt device, not a 5 volt device. The USB charging is 5 volts, not 3.3 volts. So I need to have 2 power supplies on here. I've got the big switcher, high current switcher, that will take the 12 volts down to 5 volts, but I didn't have anything that'll bring 5 volts down to 3.3. So this module right here works, but I have the power supply tuned to output 3.3 volts, so it'll run the microcontroller and all the clock stuff works, but I can't use the USB ports on it. So I need to make a second version of it, just the control board, not the display board. So I'm going to make a second control board that has the 5 volt switcher on it, and then has a 3.3 volt linear. They're small and cheap and easy, and the ESP doesn't draw so much current that I can't use a linear on it. So I need to put a linear that will drop from 5 volts down to 3.3. The other thing that I did that I've learned since building this is how to use the DTR from the serial module right there. Well, there's a socket for it anyway. I don't have a module plugged into it. How to use the DTR from the serial module to actually wrangle the program button. Normally on the ESP8266, you have to push and hold the program button and then hit reset and then do Control U on the Arduino to get it to program. And so it's kind of, and while holding the program button as the bootloader comes up. If the program button, or D0, is being held low as the bootloader comes up, then it knows to go into programming mode. It's kind of a pain in the butt to do by hand, especially with the way I put those buttons, because that program button is kind of hidden in there in that hole, and then you got to push and hold that one, and then come along and do reset. It's just kind of a pain. But there are ways you can do it by adding 2 diodes and a capacitor. You can actually have the DTR on the serial module will do all of that stuff for you. And then you just do Control U on Arduino, and it does all the signaling on the micro side. So those are the modifications I want to make to this. In part 1 of the version 1.1 series of this YouTube stuff, I actually did most of the circuit changes, although not all of them. So I'm going to go add a few things. So if I'm looking at this right, so Adafruit has done the hard part for me on signaling how to tell your device how much power to draw. I'm going to throw this Adafruit page on USB charging rates. Okay, so I have thrown that in the show notes. So this is a page from Adafruit, and she did all of the hard work on figuring out how to signal to the USB device how much power it can draw. This particular article, she only did the research to figure out the half amp and the full amp charging. So 2.8 volts on one of the lines and 2.0 volts resulted in 1 amp charge rate, whereas a 2.0 and 2.0 resulted in a half amp charge rate. But regardless, this is the important part here. The data lines just have a simple voltage divider between 5 volts and ground. So you put a specific voltage on each of those lines, and that tells it how much current to draw. The important part about this is that you can swap out resistors to put different voltages on there even after I rev the board. So I don't have to make any changes to the board to decide to use to put a different voltage on there. Okay, Kenneth is saying, resistor voltage dividers on data lines is a non-standard method used by some devices. Exact behavior varies from device to device. I'll be frank, I have an iPhone and iDevices, and it works on them, so I am less concerned about other options. If you know of a better circuit that I should be putting here, by all means, let me know. And anything that involves actual data communications with the thing, with the device that involves putting a charge controller on there, I'm uninterested in. I don't want to put that much complexity on this. So anyway, I'm going to throw some voltage dividers on the USB outputs. What was some of the other things I needed to do? So I made a lot of these changes earlier. So like there's the 3.3 volt regulator. Though I moved some things around. I haven't laid down any traces yet, so we actually need to do some tracing. And then, yeah, I want to wrap this up and place an order today. So I got to go back to the schematic and add the resistor dividers on these data lines. I also need to swap out the diode outlines on these because that's, in hindsight, I've learned that these are the wrong outlines for the diodes. Excuse me, for the diodes I have. I also put the buttons down on the bottom edge of the board where they're easier to reach, rather than having one hidden away up here in the canyon. Yeah, so Kenneth says, the iDevices use the divider method, and that is fine. So I'm on the right path for those. So that's good enough for me, for my needs. Okay, so let me make sure I've got all of the things in my list of things to do. Swap out diode outlines. Okay, let's get started, shall we? Okay, so here's the schematic. I've just got 3 copies of the USB bus stuff. I'm going to bring these down here where they'll be a little easier to work with. Oop. All right, so I need some resistors. I'm going to need 4 of them. I haven't figured out how I'm going to lay this out yet in a way that'll make this not horribly awkward. USB, oh, I never actually labeled those. USB 1 amp value, USB 0.5 amp minus B 0.5 amp. Okay. I'm going to use tags on these because it's just P4 minus, P4 plus. Drag the block. P3 minus, P3 plus. Okay. P2 minus, P2 plus. Okay. Actually, you know what? Make this all a little bit easier. What are these? 75K, value 50K. Those are approximate. Oh, this is the 1 amp. So a 43 and a 50K. Okay. So a 43 will give it the right voltage. Oh, well, shoot. Which line was that on? 43 is on the minus line. So the higher voltage goes on the minus line. Okay. That's minus, so 43K. That one is a 75K and value 50K. Okay. Yeah, we'll just leave that there. Copy block. And then edit that, so P3 minus, edit that, P3 plus, and change that value to 75K. And then copy that block again. And edit 2, edit, 2 plus. Okay. So that should give 2.0, 2.0, 2.0, 2.0 on those, and then that one should be a 2.2 or whatever it is, and a 2.0. No, 2.8? Huh, whatever it was. I'm just copying them because that's what we do. So those are the resistors. We are going to have to annotate. So that assigns all of our resistor numbers, and then we are going to go put some components on those, and all of these, oops, libraries, this is my custom one, yoink, done. Oh, while I'm here, diodes, those are the wrong ones. Diodes, SMD, it is the SMB standard. Let's go with hand soldering. Okay. Libraries, buttons, pin headers. Oh, yep. Save, okay. So those are my USB changes. Add resistors to those, lay out the traces, swap the diode outlines, and place an order. So that looks like everything I wanted to do today. At least at the schematic. All right, so let's save that. Let's generate a net. Okay. Let's come over here. And we'll load a net, but exchange footprint, change it. There are no tracks. Extra footprints, delete them. Single pad nets, okay, that's fine. So read current net list. Yeah, I know it can't be undone. Let's make sure there are no errors. Everything looks green, super green. Close. Okay. Oh, those diodes are large. Yeah. Yeah, that's wow. Okay. I don't think mine are that big, are they? Yeah, I guess they are. So this is a project I'm working on for something for work. It's a hardware random number generator, but you can see, I don't know if you can, how well lit it is. Oh, you're going to focus. Focus. All right, forget it. There is a diode right there, and that is the outline I use, and it looks pretty much bigger than the 1206s over there. So anyway, it's the right size. They're ginormous. They look ginormous. They're not actually ginormous, but they look ginormous. Those are on the top. It's not going to get in the way of that connector. It might. I'm going to move those over. Like that. Okay. That will not get in the way. All of those are on the bottom, so that's okay. All right. Laying out these resistors is going to be problematic. Flip. I want these on the bottom. Here. Yep, that's what I was afraid of. It's not going to be enough space between these. I'm going to have to move these. Shoot. Yoink. Make sure we've got everything here. Move these out. Ah, knock that crap off. Footprints. No tracks, no zones, no text, no drawings, no board outline. Yeah. Okay. So that gave me more space there, and I think I can move these up by 2. All right, let's see whether that gives us enough space. Maybe. It's going to be cozy. Excuse me. Oh, man. Okay, we'll see whether these fit. Shoot. I'm not going to be able to fit my tweezers in there. All right, well, we'll place them and see how it goes. Oh, those got to flip. Dadgummit. All right. Well, those are on the wrong side. And then these got to rotate after I do that. Yeah, those are too close to each other. I don't think that's going to work out. Move. Reference R. Nope. Move. Footprint R. Footprint R. Dang it. Ground. Okay. Move. And then that one. Oh. Damn it. Thank you. The problem is that the text is all the way over on the right-hand monitor, on the right-hand side of the right-hand monitor. Kenneth is telling me that just informed me that I have been showing you my face this entire time instead of actually the work I was doing, which makes me feel goofy. We want to see your screen. Oh, KF7IJZ. Jeremy says, hey, bud, can't stick around, but wanted to drop in and say hello. Well, thank you for stopping by, Jeremy. Have a great Sunday. And Kenneth, thank you for waving me down. So the question is, these are way too close together. Are they actually going to work? Or is that going to over... Yeah, see, that's right on top of it. See, the other option is to go to a smaller resistor outline. But I like my 1206s. Or I can do a different grid. Ha ha ha. Inches, track, via, grid. Let's go to a 5 mil grid. No, hang on. So put that back to where it was. There we go. We'll make it so that they just barely overlap. Wait, is that right? Oh, I went awfully quickly. That's why. Okay. Yeah, we'll do that. I think this is the better bet. Okay. But dad crap is the best crap. Wish I could spend time here, but holiday, family crap, dad crap. Yep. No worries, Jeremy. I get it. I've been doing an awful lot of I hesitate to call it dad crap because I've been having a great time with it, but a lot of dad family obligation stuff lately in personal life, and so that's why I haven't been streaming for a while. Today we were planning on going out and doing a little bit of geocaching, but I don't know if you can tell how orange the sky is behind me through those through that window. In fact, I'm kind of backlit, aren't I? Maybe I should drop that again. But there are some pretty gnarly fires going on here in California right now. And some friends of ours have been evacuated out of their house. To the best of my knowledge, nobody we know has actually lost their homes. But it's getting pretty gnarly and pretty bad out there. So stay safe, California. That is pretty bad. I am going to drop my curtains. I'll be right back. Which sounds like a euphemism, but I promise it's not. I just realized I'm not actually listening to anything. I don't need my headphones. Kenneth, yes. I won't quote it on this, but yeah. Yes, it is. Joel, thank you. The fire is not anywhere near our house right now. The fire is about 80 to 90 miles south of us. Maybe closer to 100, but it's pretty far south. So we are not in any immediate danger, but the smoke is getting blown over our house. There's ash falling on our car and fun things like that this morning. So it's getting to be pretty scary out there. Okay, outline-wise, I think that's going to work out okay. I am kind of curious what that's going to do to the fills, though. Let's take a look at turn off the top layer. Not an ideal way, but it'll do. And then we're going to have to via those 5 volts up to the top. We'll do that when we're ready to start laying out traces. Okay. That works out. What were some of the other things I wanted to do? Lay out resistors, lay out the traces, swap the diode outlines, which I've done, and then place an order. I think I'm ready to start laying things, or to start drawing traces. Although that made more sense to be on that side when this was on the other side of the board. So let's move these footprints over here instead. Oh, shoot. Okay. Are we ready? I think we're ready. William Osman on YouTube. Refires in houses. Oh, okay. Who is William Osman? Give me a little... so this is Joel Hudson talking about how I should look up William Osman on YouTube regarding fires in houses. I don't know who that is, but I'll take your word for it. Tell me a little bit. Who is it? Yeah. Aesthetically, not the way I would normally do it, but this will do. Not critical. Okay. Let's do some vias. Oh. What's that going to do? Okay, that's legit. We're going to have to do that on these sides, too. Okay. Okay. And same here. Okay. So those are done. Now let's see here. I want to do this. Design rule check. I want, nope, cancel. Not what I wanted. Design rules. I want my, let's do a power. Oh, 2, 5. Okay, so that's the power one. 3, 3, 5, and ground. Yeah, those are the ones I wanted the power. So those are the nets. So what I've done is I defined a new net class. Nets are the traces and the these little white lines and everything. So every connection is a net, and certain nets, default. You have a certain defined track width and via size and all that fun stuff for these. What I've done is I've created a new class called power, and I have put the 3 volt, the 5 volt, and the ground into that power class, and I've given it a wider track width. So that is how you, I didn't care about it for these, but that's how you do, that's how you define track widths for different kinds of traces. So for example, I'm going to do that. And then I'm going to do that. And that's going to get me my 5 volts. And then I want a via on the capacitor so that the power has to go across the capacitor before it goes to the USB port. Oh, except for the fact that the USB port is going to be tied to the top pour, isn't it? Shoot. Yep. Not ideal, but we'll deal with it. Okay. And we'll just leave it like that. Okay. Aha. Okay, so let's start doing this one. This one I can do it that way because it is not tied to the top side. So we will via on both of these. So this is supposed to be like a 10 microfarad and a 0.1 microfarad filter caps coming into this. He's homeless now. He likes to make things with friggin' lasers. Aha. He cut a record with his laser engraver. Oh, nice. On chipboard. Okay, William Osman, and he's now homeless, presumably because of the fires. That's no bueno. That's always scary as crap. You know what? I don't want that one. I instead want to do it this way. And then I'll come over here and do a via there. Okay. So now, this is kind of what I was thinking of doing on the other side. So now power comes in from the top layer through this via, through a trace to that capacitor. It has to pass under the capacitor first, then under that capacitor before it goes into here. So the power has to pass both of the filter caps before it goes in. There's no way for current to go directly to this pad without first passing underneath these capacitors for filtration. That is what I was trying to do over here, and I suppose I could still do it by putting a keep out zone around that 5 volt pad there. But honestly, I'm not going to worry about it too much. Kind of splitting hairs here. So we'll do that. And we'll do that. And then, unfortunately, I need to get it through there to there. Okay. He lost everything. Very sad news. I'm sorry to hear that. Yeah, we have some friends who have not lost everything, but came darn close. They were about 3 houses down from people who did lose everything. It's kind of terrifying. So I got to get that 3 volt around to that side and to that side. Maybe I do it this way. I will route signals on top traces. Okay. Okay, so this is top, this is 5 volts. Trying to figure out what I want to make sure that I don't cut off. So 5 volts is coming from over here. Just going to thicken up those vias, or those thermals a bit. What is that? DTR. Oh, D0. No. Serial module. So that's DTR. I don't remember it being two series diodes like that. Maybe I'm misremembering. doing that. Oops. So I can run transmit. This would be a lot easier if my top layer were visible right now. There we go. And then I need to get receive over there. So let me start on the top. And then via down to the bottom. Go next to there. And then this one, I'll just go straight down. Okay. Aha, here's another pad. I knew there was one. Okay, so con1, pad 1 needs to be added to the power design rules. Con1, pad 1, power, yoink. Okay. So, boom. Yeah. I want it right down the middle. There we go. Okay. Those two, and then those +5s need to get routed to the top. Get via'd to the top. Okay. I think I want a little bit more connectivity than that, because that's going to be where the bulk of the current is going. Oh, I guess, no, not including the charge. Can do that without getting, I can't, dang it. All right. Oh, poo. There we go. So what does that look like? On the top looks good. We just got a bunch of vias connecting to the 5 volt. On the bottom, yeah, doesn't really interfere with the ground plane at all. That's good. That's good. Okay. So we've got D0, D2, and reset that need to get moved over. And they all cross. Of course they do. Okay, so what does the top layer look like? What's the pour? So that's a 5 volt. Okay, I can at least go on the top layer to escape this. And then via to the bottom. Oh. No, I don't want a via to the bottom. Maybe I do. Okay, where's D2? Let me get D2 out first. And we'll via to the bottom right about there. I can see the damn bottom. All right. Oh, I can't because I got those. Oh no, that's right. We're going to go top first to escape out of... What the heck? There we are. Come on, Smitty. And then we will via to the bottom right there. Okay. Let's go. Time to swap the button order. How so? Oh, I see what you're saying. To make routing a little easier. You know, Kenneth, every once in a while you come up with a good idea. I knew there was a reason I keep inviting you to this. Footprint, which one? Nope. Oh, wrong one. Button. It is a little easier, isn't it? Crazy talk. Okay. So... Shoot. There we go. No. That's kind of insane. That's a little less insane. Going to leave that area there without a fill. And this one can rotate. Oh, that's right. Wait a minute. want that to actually go around, don't I? Will you let me view that soon? Or that close? Apparently you will. Oh, voids there. Yep, okay. Kenneth just suggested that I rotate that button, which I have already done. So let's go view our planes. Yep, see? All of that void space there bugs me. But I want to make sure that I've got some good ground connectivity from that side to that side, because all of my USB charge current is going to be coming through there. And I kind of don't want that one. That's my input. I want to put a keep out there. I don't want any current returning through that bottom copper. No copper pour. There we go. So that will force all return current to go into this pad on the regulator, which will force all of the current to go through the regulator underneath the voltage sense and detection and all that stuff. But I do need, okay, hold on. That's not quite what I needed to draw. I need to draw bottom copper, no copper pour. I don't actually want to keep out. I want to put a second copper pour there. Or I just draw it as a trace. Okay. So that is another. Oh, nope. Ground is already in that one. So let's draw this pad. Track. Oh, shit. Oh. Okay. I unfortunately set the keep out zone as no tracks, no VS. Nope, I just want no copper pour. Okay, let's try again. I'm not going to bother getting through there. Whoa, nope. That's what I was afraid of. Dadgummit. Ah, come on. All right. Let's redo the pour. Route D0 between pins 4 and 6. What are you talking about? D0 between 4 and 6. Oh, and bring it down that way? All right, I'll take a look at that in a second. Let me get my keep out pours going here. Bottom, no copper, that's all. Okay. Let's do this properly. Okay. Whew. Grab the right one. Okay. Bottom, ground. Okay. And then we are going to have another copper pour still on ground. Should probably soften those corners a little. There we go. Okay. That will force all current between the power connector and the rest of the circuit to go through the voltage regulator, which means it will actually regulate current properly. Okay, now, Kenneth was saying he wants me to look at this. What did I do? He wants me to route it through there. Okay. Let's turn off our pours. Let's start out on top. It does look better. Thank you, Kenneth. Huh. It's going to complain that that ground and that ground are disconnected. And that is true. And I'm going to let it continue to complain about that. So, that looks done to me. It's going to complain about one disconnected. Yep, but that's the ground. We know about that. I guess ideally I would go back to the schematic and split those into two different outlines to make that go away. Let's go see what happens when I do that. There's the power module. Okay. So which one was which? 4 is the output. Okay. So delete that, delete that. Oops, we'll have to put that back in. Delete that and delete that, and we'll just do it this way. We won't bother putting a name on it. Save that, generate a netlist. Go back over here. Excuse me. Read the netlist. We're not actually changing any things. We're just changing the netlist, so that's okay. Okay. So, what is the name of that net? Con1 pad 2. Okay. So we are going to edit that outline, and we are going to change it from ground to Con1 pad 2. And we are also going to go to design rules, and we are going to add Con1 pad 2 to the power so that it gets the new design rules. So let's go take a look at that now. Looks pretty good. All of that is disconnected. So 5 volts comes in here. We're not feeding any power to the serial module. That's good. 5 volts comes in there. It is fed along here to there. That's good. Comes along through here, comes around. 5 volts fed through there. You know what? Again, let's do this right. Let's put a keep out here. Top, no copper pour. Okay, so that disconnects that 5, which means it is going to force it through my caps. Okay, so now I need to go back here and actually do I want to make that go in a line like I did over there? I kind of do. So let's delete that one. We'll make it go like that. And then we will via it right there. Yeah, Kenneth was telling me about I have to have 2 different ground nets. Yeah, I know. I ended up not bothering with another named net and just ended up drawing a trace. But using one of the other nets would have been good too. Whoa. Okay, try again. I think I hit too many keys. Okay. So the 5 volts has to go into those capacitors before it'll get to the thing. Okay. I think I'm pretty happy with traces. What other things have I screwed up on? Next thing to work on is the silk screen. Okay. I don't want to render the coppers or the pastes. I do want to render the silks, not the masks. Drawing user. Nope, keep the edge cuts there. Margin. Courtyard. Fabs. Okay. Ah. So, values are the ones that don't get rendered into silkscreen. References do. So I need to go in. Oh, Shoot, that's the problem with doing my custom ones, is that I put them on a different layer. Okay, forget it. Kenneth's favorite part of my work. Whoop. Value. Ugh. I hate references. I never use them. I always put values directly on the board. Exploding Lemur is asking me a question. Oops. What is... Oh, your face palming me, having to do all this stuff. Kenneth just face palmed me in the chat. To be fair, he's not wrong. So this is the one I have to be careful about because I have different values on each of these. Wait, what? Oh, that's the one that has different values. Okay. That's a 43, that's a 75. Okay. Okay, good to know. The top one is the 1 amp. Beginning to think that it might be better to do the bottom one as the 1 amp. But, okay. C5, R1, U1, value 10K, 10 micro. don't know why those A and Ks are there, anode and cathode. I don't think I've ever seen those before. Okay. Everything is off the board that I don't want. Let's go put some text in for the things that I do want. Oops, hold on. No! Grid. Go back to 25. Reference. There we go. All right, text. Reset. Silk. Oh. He asked if I had any M2 screws and standoffs. And I said, no, I've standardized on M3. Apparently he meant M2 form factor SSDs. No, none of those either. Control, because it is no longer a program button. Okay, so I do want to put a label by that. So we'll do one here, text AP1117D33. Make that a little smaller though. We'll do bottom silk. Mirrored. Go. Okay. Edit. 075. Okay, I think everything else is labeled. Oh, no, I want to mark that one as the 1 amp. Definitely. Copy. One amp. Copy. Oh no, shoot. Yeah. One amp, 500 milliamps, and then we will copy that one down to there. Okay. So that's labeling the USB ports. Well, you probably won't be able to see that. So okay. What else needs to be labeled? wish there was a click 'em all button. I need to know which one of those is positive. Okay. I'm going to go ahead and move these over here, even though the only ones we care about debating whether I want to draw a line through the powers because we're not actually using them. Silk. Okay. What else? Text P6. Okay. What else am I missing? What else is standing between me and placing an order? I think that's all the work I wanted to do today. What do you think, folks? Let's do this. That's the top copper layer. We got 5 volts coming in here. I kind of want to do a keep out in that corner. But we got 5 volts coming in here from the regulator. Comes around, powers the display through there. It powers the USB charging over here. And it comes up and it powers the 3.3 regulator, which goes into the 8266 here. Comes in through that via right there. Let's do a design rule check. I just need to put my text on it. Okay. Front silk. What did I call it? Did I have a label on it before? I don't think I did. Huh. Oh, wait a minute. I had to bodge a resistor onto the bottom of this. I'm remembering now. I don't remember what that resistor did. Let me go look it up. Hang on. Needed a screwdriver from the workbench. I'm trying to remember whether, because I had a pull-up on reset, but I'm wondering that I'm thinking that I didn't have a pull-up on the program button. And that it would continuously go into program mode on startup, whether you wanted it to or not. So D0 needed a pull-up. is what I'm thinking. I'm going to pull this one apart and see if that's what I actually did. Board. Why does my video seem to be frozen? Maybe not. Okay. Come over here. So that's the back of the display board, which is just a bunch of bypass caps for each of those LEDs. Probably more caps than we needed, but and then there are the LEDs. So the display board is pretty dirt simple. It just has a 6-pin header here, and each pair of pins is, one pair is ground, one pair is +5, and the other pair is D2. I did it as a pair because, quite frankly, it's easier to keep a 2x3 vertical than it is a 1x3. Okay, so what did I do on that? That is between D0 and 3.3. Yeah, I had to put a pull-up on D0. I did a 10K pull-up on D0. Let me add that. Good news is a pull-up will be pretty easy to add. Knock it off. R small, look at that. Copy that. And we'll do a pull up to 3. Value 10K. Oh, hey. Kenneth likes to see my face. So literally just a D0 10K to 3 volt pull up. Save that, annotate it. Yep. Let's go give it a outline, libraries. That. Oh, yes. Okay. Save that, save a net, generate your net, go there. Okay, now we come over here, we do a load a net, and there should be one additional resistor. Right there. Oh. So those resistors look like they're on top of each other, but this resistor is on the top layer and that one's on the bottom layer. And so that just vias down to the 3.3 volt, which is right below it. So that's my pull up on D0. Well, that was easy to add. Okay, now I think I'm ready to order. Let me look. What are the things that I have to bodge on this? Nothing. It's looking pretty good to me. So we've added the USB ports. We put the resistor dividers in there so that we can specify how much current each of the ports can take. We've done the bodging of that resistor there to pull up D0 so that it will actually boot up. We have put all of the things in to allow DTR to control the program. That's what those diodes and that capacitor are. We've routed all the traces. We've got our control and our reset button. I don't even know what control is going to do yet, but we got the button there. I think it's in pretty good shape. So let me put my name on this somewhere. Don't have a whole lot of space, do I? By non-commercial, share alike, Smitty, Halibut, 2017. Actually, let me do these one at a time. Back silk mirrored, left justification. Oop. Edit. 5. Actually, I lied. Keep those at 6. And then we'll make that 1. Okay. Oops. Copy. Bedside clock. Now, Creative Commons by attribution, non-commercial, share alike, Smitty, Halibut, 2017, Smitty, Halibut. Okay. Yoink. Let's move that down a bit. Okay. I need my fish. Where do I want my fish? Front mask. 5. 5. We'll do left, normal, normal, and then wow, why was that so hard? There we go. Are those gonna, what layer is that? Front mask, solder mask. Yeah. Yeah, that's what I want. The world is made better with ASCII art. You know it to be true. Okay. How long have I been streaming? Hour and a half. What am I missing? I don't know if Kenneth is still around, but anybody else? We've got 4 people watching. Oh, just lost one. 3 people watching. What am I missing? This looks like it's ready for me to order. I'm looking for a sanity check to make sure I didn't miss anything. Right. Let's do this thing. Let's see what Osh Park says. Oh, whoops. What? Is it in my other procs folder? It is. Haha. Okay. That's the one that I just saved. Let's see what you think. It's always fun when you can get to the end of a project and order something. Osh Park does not pay me. It detected unsupported drilled slots. Where? Oh, dag nabbit. That's right. This outline uses drill slots there. Shoot. But otherwise, this is looking pretty good. In theory, Osh Park are working on automating the ability to do drill slots like that, but it's not there yet. So all of this looks right. We've got the labels on those. 50, 75, except for that one, which is a 43. But 50s and 75s, 50s and 75s. Other than that, I'm not seeing any problems. Okay. So, one way to deal with that is to drop some pretty gnarly layer alignments. No, shoot. There used to be a way to like drop a pad on there, or do I have to use a different component? Capacitor connector. So that's the one that I've been using, but it's got slots. I thought there was one that had big holes in it, which is not ideal, but nope, that's okay. That's the one I'm thinking of, but it's still got slots. Well, that's unfortunate. Did I make one? So this is a library with all of my own outlines in it, like that one. That's the one. Okay. All right. So I knew I had one. So I've got to go back to here. Yoink. Just knock that off. And go there. And barrel jack. Change that to... See, if I were smart, I would have written it down. Power jack. That's it. Is that the one? Yes, that's the one. Okay. Save. Come over here. Save. New net list. Generate. Yep. Read the net list. Exchange footprint change. Read current net list. Okay. Oh. Footprint. Con 1. Hmm. Okay. I think that'll be a drop-in replacement. What does DRC think? Yep, we're good. That was a little close, but we got there. All right. Start over. All right. No errors. Continue. Let's take a look at what this looks like. That diode isn't too tall for that, is it? Where's my diode? There it is. Nope, we'll be okay. What do y'all think? That's a lot of thermals right there. All right. I think I'm ready to pull this trigger. Approve and order. And then from here is where it's going to start displaying my personal information on the page. So I'm going to do that. And we're going to wrap up because it's also lunchtime. I am hungry. I've been streaming for an hour and 40 minutes now, so it's time to get moving. Thank you very much, everyone, for joining me. Hopefully this was entertaining and or educational. I'm finally going to get this bedside clock thing off of my desk here. I've had it on my desk and trying to encourage me to actually get off my rump and do this. So it'll be nice. I'd like to actually have this on my bedside. I'm Smitty Halibut. You can catch me on Twitter, SMITTYHALIBUT. It's probably the best way to engage with me, but also down in the comments below. So let me know if you have any questions or comments about my work today or anything else that I've worked on. Subscribe if you enjoy this kind of stuff. I've also got a few shorter form, more edited videos that I've done. I just did one about a week or two ago about a fan dipole and how I built my fan dipole, specifically how I linked the shorter pieces of the fan dipole to the longer pieces, so that at the ends there was only a single rope to anchor on each of the ends instead of having to have a separate rope for each of the fans. So yeah. In current event news, the Micro BitX was just released by Asher Farhan. So go check out hfsignals.com, not hfsigs, but hfsignals.com. It's his new site where he's selling the Micro BitX. It's $109 shipped from India, at least until Christmas. He said he was going to up it by about $20 after Christmas, and it's December 10th in 2017 right now. So in probably just a couple more weeks, the price is going to go up a little bit. So head over there and order that one. The Micro BitX is a multi-band version, kind of like the BitX 40. Covers, what is it, 80 meters through 10 meters, I believe. It can probably be hacked for some VHF and UHF and maybe even for 160 meters. But kind of a multi-band version of the BitX 40, which was just a single band. It's a little bit different architecture, but overall it looks like a great radio. I've ordered mine. It's on its way. Happy Christmas, Merry Birthday, whatever. To me, go forth and do some awesome things. Thank you very much for watching, and we'll catch you next time. I'm Smitty Halibut. Be good humans. Thank you. And we wait for the stream, for the thumbs up in the stream, and then I hit stop. I'm waiting, doing my little dance. There's the thumbs up. Have a great day, everybody.